So first, the evolution of asynchronous I/O we have over the years in Samba. Then the asynchronous query directory, Ralph also talked about earlier. Then our current impersonation module. Then a failed attempt with the TEvent wrapper infrastructure. And yeah, then a modernization of the VFS using add calls and so on. And then a proposal for a future impersonation model and a way to balance between asynchronous and non-asynchronous. So in Samba 2.2, we first released an VFS abstraction. It just had 34 operations, basically POSIX like syscalls, open, dir, open, close, and all sorts of things. And a few NT-like calls to get the NT echo and set the echoes. And these were only supported with one module per share, so there were no stacking at all. With Samba 3.0.0, we made the SMB VFS layer more flexible. So each share was able to get a list of modules specified, and the SMB layer would call the first one that may or may not call the second one, and so on, until they get to the default backend. With that infrastructure, we get audit modules, recycle bin module, even shadow copy data were possible, and quota implementations. Then with Samba 3.0.20, we added support for the POSIX AIO API, where you have AIO read, write, suspend, return, and so on. But that API is really complex to use. It uses real-time signals for the completions, and even the glibc wrapper had a mutex per file descriptor, so you can't have really multiple pending I/O requests per file descriptor, which makes it completely useless for Samba. Then with Samba 3.3, Volker added a module called AIO fork. It uses, yeah, Jeremy?
I just want to comment that I didn't know about the glibc restriction when I added the POSIX AIO.
Okay.
Otherwise, I wouldn't have done it, because, as you say, it made it completely and utterly useless.
Okay.
It was only after an OEM said, why isn't it async?
Okay. So
I actually dug into the glibc code and found it was broken.
the comment from Jeremy regarding the POSIX AIO, at the time he implemented that, he wasn't aware about that mess in glibc, and he just found out later. Yeah, the AIO fork, it uses shared memory, one shared memory region per child process. It forks a handful of childs and then communicate with them over socket pairs with FD parsing. And the main process sends requests and gets the completions over that channel. And because it's a socket, we can plug that into our event loop nicely without signals. Yeah, that supported multiple pending operations on a file descriptor, but as you can imagine, having to fork and doing the parsing via the kernel adds a little bit of overhead, but for slow file systems, which are really slow, it was better to have that instead of doing everything synchronously. With Samba 3.6.6, we added an AIO pthread module. We have a generic pthreadpool layer where we can have a pool, maybe I guess the default is 100 threads or so, where we can add a job to a queue and threads are started on demand. The first thread will just grab the new job from the queue and execute that. And because we are scared of threads, we try to isolate that as much as possible and only allow single blocking syscalls in the helper threads, no logic, just waiting there in block state, and then collect all the results again in the main thread and do the logic there. And this used pipes for completions and a mutex queue for requests. With Samba 4.0, we changed away from emulating the POSIX AIO at the VFS layer. So we turned everything into our TEvent direct-based send and receive function pair. So our aim is to just have one async programming model, and that is TEvent, and it turns out to be quite nicely. And the fact that it's used all over the place in Samba makes it relatively easy for people to understand it because it's every time the same. So we got SMB VFS pread send. It takes a memory context. The second one is always the event context, and it returns the TEvent rec request handle. The caller is able to set a callback function, which gets notified when it's done, and then it's the duty of the caller to call out to the receive function and pass a request handle in order to get the result. So there's no real callback that, in the case that the lower layer pushes stuff to the upper layer, but instead it just notifies the upper layer, and the upper layer then goes and fetches the result. The AIO pthread module was then moved to be the default in the default backend, so no more VFS modules were needed for async I/O, and we then added a layer on top of our pthreadpool implementation to make it easier to use with the TEvent send and receive logic. But Samba still has an AIO pthread module, but that implements something different now. It implements async open for file systems which are slow in creating new files. It uses the ocreate and exclusive, and it's Linux only because we need to get the path-based on the path-based operation, get the impersonation right, and the only platform that supports that is Linux, where we can have credentials per thread, basically. But this time, also glibc is smarter than we would like it to be, and we need to bypass it because when you set credentials in a thread, it implicitly resets the credentials on all threads. So we need to use the syscall directly in order to bypass glibc. Then later, or also in 4.0, we added an AIO Linux module which uses the Linux AIO API with IO, prep, pread, pwrite, and so on, submit and get events. And for completions, it uses the event FD from the Linux kernel. But this time, again, the API is not really useful for Samba because it requires ODirect to be used. And if you don't do that, there is no async I/O, just synchronous I/O. And in 4.9, it got removed again. Then for 4.12, I'm planning to add a module using the new I/O ring infrastructure from the Linux kernel. That looks very promising. It's basically some kind of ring buffer in shared memory between user space and kernel. And user space adds more requests to the queue there, then in a logless fashion first add the entries to the queue and then update the queue pointer. And that means we don't need to do any special locking between user space and kernel space. And on the way back, we just look at the receive queue and check for new entries there. There are two modes. The first one is that the user space would enter the things to the queue and then have one syscall to trigger the kernel, and then one syscall to watch for results. But there are also modes where you can say, please kernel, keep a thread open, a kernel thread that polls for 1 second or so and does the work without needing the user space to submit explicitly in order to get the I/O done. And that even supports async I/O with buffered mode. If you're more interested in that, there's an LWN article about that feature. It's available in Linux 5.1. And yeah, I have a patch for that on GitLab, but I was only able to compile it and don't have a system yet where I can test the new kernel. Maybe I can do that during the week now. So, next topic. We had problems with async SMB2 Query Directory. The problem is that readdir, for example, just returns the type and the name of the entries in the directory. And for SMB, we need to return more information, more metadata information for each name when the client asks us. For example, we need the up-to-date write time. We saw that in the logging TDB. That's the database Volker was talking about in his talk. Then we have DOS attributes where you store if a file should be hidden or things like that. And that's typically stored in an getxattr on the file. And then, of course, we need the information from the stat buffer. And in a cluster, there's the problem, the contention when you have a directory with, let's say, 10,000 entries. You need to fetch 10,000 logging.tdb entries from for the 10,000 names, and that doing that in a synchronous fashion adds latency. So we invented a dbrep path record send and receive function where we could batch the requests to CTDB and fire them off, let's say 200 a time until the CTDB socket is full, and then we wait for the results asynchronously. Yes, so then we face the second problem. Some customers have file system where getting the X address of a file was expensive, much more expensive than the stat call. And because of that, we added VFS getxattr getxattr add send and receive hook into our VFS layer. And on top of that, we were able to implement get-DOS attributes, send and receive. And that also lowered the overall latency because we could wait within threads to get the X address instead of doing that synchronously, waiting for each one to finish before starting the next one. Because that adds more latency or more overhead for fast file systems, this is still off by default. But if you have a file system that's, yeah, question?
Which file systems do you see this difference?
That was proprietary file system from a customer. Yeah, Volker?
What I hear is that all Fuse-based file systems that are much slower because in Fuse the normal state information is cached in kernel, but for getxattr you have to go to the Fuse server process.
Okay. The question was which file systems bring this slow getxattr calls, and Volker said it's typically Fuse-based file system where stat information is cached in the server in the kernel, but the getxattr calls always go down through to the file system. So you may wonder, having getxattr add, send and receive without having a getxattr add syscall. But this is actually what we like to have, and we found that it's possible to use fchange-dir and then getxattr with the relative path name to simulate that. And in order to do that in our pthreadpool, we need the ability to have a per thread current working directory. And on Linux, that's possible with the unshare syscall, specifying the clonefs flag. But sadly, some containers, I think Docker, maybe others also, reject unshare because it's also used to create network namespaces and other namespaces, and yeah, that's so we can't even rely on it on Linux when you run inside a container. It's a bit sad, but that's how it works currently. So in the end, we hopefully get something like get file info, send and receive. That would be a future goal where we can more or less like the statx call, but a bit at a higher level, specify which information we want, and then the backend goes and fetches all we need. So it may skip getting the write time from the login TDB if we don't need it, or also call or skip the call to getxattr and specify flags to statx, and that may help in future to bring down the latency even more. Maybe we can also have the statx and getxattr in one helper thread. Typically we just want one syscall there, but having two with a slightly very simple logic might be okay. So our current impersonation mode is the following. When we receive an SMB request from the network, we process it, we look at the session ID, look up the session, look up the tree connect, and at the tree connect structure we have the impersonation information available, like the UNIXToken with UID, GID and groups, but also the NT token, and yeah, we change basically the effective UID, GID and groups array in the kernel, and change to the root of the tree connect, and set also some global variables which are used for the substitutions, like %u for username and so on. And yeah, we have quite some global state we reset with this change to user and service function. So the fact is that the SMB VFS layer relies on the impersonation to be performed already. It doesn't actively take care of it, so it just assumes it's in the right state and does no checks. There are special cases where we need to override that. For example, when you try to get the nt-echo on a file, which is stored in an getxattr, we need to change to root with the become root function and then read the nt-echo as root. But these are special cases. There's also the change to user and service by FSP that's used for the offload write, which is our internal implementation for the copy chunk feature, where you can basically provide a handle to a region in a file as source and then write that to a destination FSP without having the client seeing the data. And that's even possible across shares, so we need to switch the impersonation between these shares. The situation with path-based operations like open, these are typically asynchronous when we wait for op-block breaks. So this is done more or less by the fact that we wait for the op-block breaks to happen, then we reschedule the whole SMB request and then completely pass it again, looking at the session ID and so on, and do the impersonation again. And we even do that multiple times, not only 2 times, but maybe in between there has another conflicting opener opens the file and we need to retry and so on. And for the backend it's not possible or hard to maintain state between these calls. But it can rely on the impersonation to be done because we always completely replay the operation. Okay, so our goal was we want to make more path-based operations be asynchronous. The typical choice is, as I said before, TEvent rec with a send and receive model. But that means the send function is called with the correct impersonation, and it gets an event context and can fire any events or so. And when the event handler happens, maybe the impersonation already changed in between, because on a terminal server you have multiple sessions or you have multiple shares with fourth user being set. So you're really not sure you're in the correct state anymore when you resume processing the asynchronous operation. And as our design was that the SMB layer takes care of it, the idea was, why don't we add something to TEvent, a wrapper infrastructure where we can run hooks before and after each TEvent handler, and that way we would be safe and all events would implicitly get the correct impersonation. Basically the SMB server would prepare such a wrapper with hook functions and then have that per tree connect and only pass this special event context down to the VFS layer, and that would implicitly take care of everything. And it would not be possible for the VFS module to forget about the impersonation. A similar problem happens with the pthreadpool infrastructure. So I also thought, well, it would be a good thing to run an impersonation hook before and after each syscall, and let the SMB server provide special thread pool wrapper contexts and just pass them down. And yeah, then the VFS module was free to use the thread pool with the path-based syscalls, and everything would be fine. But the problem was this is completely complex and not really obvious when impersonation happens, especially when we simulate it become root and switching from the normal impersonation to root and maybe to the other share for the copy chunk implementation. It also added some lockless thread interaction for the thread pool. Yeah, that code was in master for a while, but then get reverted before 4.10 RC1, and we added back just explicit impersonation in the few cases we had implemented for the async get DOS attributes thing. Then our way to the modern VFS layer. So as Ralph already mentioned, we disabled SMB1 by default in 4.11, and yeah, we sadly can't remove it in near future, but for now it's just disabled and people need to actively enable it, but hopefully someday we can remove it. And as SMB3, SMB2 is a handle-based protocol, there are just a few situations where we need to take care of path names. That's obvious, the create function, the create call. It gets a full path name relative to the share root, and everything else needs a file handle from create to operate. Then query info returns the full name in a normalized way, but that's not much of a problem. The only thing is that query directory returns relative path names, and in our code where we get the details about all the directory entries, we need to use path-based operations, but just within this directory, and we can rely on relative names there. For set info, we can have the set file link information or rename information, and these also take the full path relative to the share root for the destination target, but the source is based on a file handle provided by the create function. That means if we base our VFS on what SMB2, SMB3 needs, we can simplify our VFS layer a lot. And many operating systems have the new rename add, link add, open add, and so on syscalls, and we are slowly moving, or you can also say Germany is fast in it, adding these to our VFS layer and make them available. We're not really using them yet in a file handle based way, but the first is just to add them, to have them available, and that will hopefully in the end allow us to remove a lot of legacy code. So with that in mind, and the failure with TEvent wrapper, I thought about a new model for the asynchronous calls or impersonation in general. there are a lot of POSIX calls or backends without POSIX syscalls, like clusterfs and ceph, which use user space libraries instead of syscalls. They would be able to do the impersonation via the user space library without setting global state in the kernel. Yeah, they work with custom impersonation, and there's also a lot of file descriptor based syscalls which also don't need impersonation. So our strategy would be that we move the impersonation from top to bottom, meaning that the SMB layer would no longer do any impersonation. It would just pass down some kind of token through the layer, and the VFS module needs to decide if and where it requires the impersonation. Of course, we will provide simple and easy to use and easy to understand helper functions. And every VFS call would get that as the second argument, I guess, after the VFS handle argument. And the fact that each function gets that as an explicit pointer, it makes it obvious for module writers that the strategy has changed and they have to take care on their own. So the remaining thing is the global state for the %u substitutions and so on. And I took a look at what we currently have, and it turns out that we have 54 global and 27 per share options which support that. But I think a lot of them, or a few of them, can be changed and don't really need that. And the rest could be converted to having an explicit LP-CFG substitution context where we store the information for the substitution. And then we just have to go and fix these, let's say, 60 remaining places where these things are called, and just add an explicit pointer there. And then we are rid of the global state. So the API, the core API for the impersonation is this. We have an SMB VFS impersonation create function that just takes the auth session info. That's the structure we get from the authentication. And then, of course, there's the new substitution context, and then it creates SMB VFS impersonation structure. For some cases, we will need to get references to that. So the idea would be that every open at the SMB layer would get such a reference from the tree connect, so that we have that on the open, and that may simplify the handling for backup intent. There we could just have a token on the file handle that represents the root token, and then every operation on that handle implicitly got root access and do the backup intent stuff. Then simple helpers to get the session info and the substitution context out of it. And then the helpers to impersonate actually the UNIXToken. The key thing here is that each of these impersonation functions, context pointers, gets the unique 64-bit cache ID. So we would just have a global counter which is incremented with each allocation, and that should be good in the space of just one process. And that means in the impersonate UNIXToken function, we could just check a global variable with this pthread and check if the impersonation already has the correct token, and if so, just skip it, and if it needs to change, then we reset it. And for the legacy code path where we call become root or unbecome root and so on, we can have a impersonation cache reset function, which then resets the VFS state. And on system which support that would even be possible to be called in a thread, but we need some helpers to detect that. Yeah, then the next helper function set would be that we hide the call to impersonate UNIXToken and let the VFS modules don't do the syscalls directly. Basically, we would have something like this. Just a helper macro because it's used all over the place. And here you see the abstraction for the, or not the abstraction, but the wrapper for the rename add call. It would just get the impersonation pointer and then the typical arguments for the syscall, and it would just do the impersonation and then call the syscall. And in order to prevent mistakes in modules, we would just define the rename add to something that breaks the compiler. And we would do that basically for all syscalls we expect modules to use. So now the question is, do we want to have each operation asynchronous? And I think from the high level point of view, so from the SMB layer, we should aim for that, because there are a lot of OEMs who use Samba as a gateway to cloud storage, or use HSM with tapes and float disk and so on. But modern storage is very fast, so we have NVMe SSDs, persistent memories, and they require minimal overhead in order to perform well. So, and it doesn't make really sense to go asynchronous with that storage. And we should avoid maintaining the TEvent rec states at multiple levels in the VFS stack, because, as Volker already mentioned, all allocations, we don't get them for free, and this adds up, especially if you want to serve such fast storage. And because of that, my idea was that we would have 3 functions per call. First, the async version, and that can decide, can I operate directly and don't need any asynchronous overhead, but it can say driver blocked or evoke blocked, depending on the prototype of the function. And then the SMB layer would call the asynchronous function. Or there might be a mid layer which does this in a generic way. Things get a bit more complicated when we have to deal with our database logs. If you were in the talk from Volker, we have this logging database which holds the open file database. And in order to prevent races and so on, we need to protect the code path with multiple low-level operations and make them atomic for the SMB client. And with that, it's not so easy to use our TEvent rec model. And as a start, because we had a customer, an OEM, which needed asynchronous byte range locking, we came up with the idea that we for now can just use status retry in order to let the SMB layer know that the backend wasn't yet able to decide if there's a log conflict or not. And then we provide some helper functions where, so the prototype of the log BRL log Windows function is not changed, but the byte range log pointer, from there we are able to get request memory context and request GeoID, which then could be used by the backend to allocate some state for the request and then also match the request on the provided GeoID. So that's basically my talk. Do you have any more questions? Jeremy?
So normally we emulate the asynchronous stuff using synchronous. So in that pthreadpool example, we would always use the send receive, and internally if we don't have asynchronous pthreadpool, we would basically just call pthreadpool and then pretend that it went async, right? And you're essentially turning that around so that you never allocate the TEvent ranks. Is that your...
Yeah, more or less, yes. So at the SMB layer, we would allocate the send and receive pair for the highest level. So the first layer gets it, but then in the send function it detects it can go synchronous and then directly completes. And
But isn't that what we all, I mean, do you need the synchronous? Because what I've been trying to do is essentially remove any of the synchronous calls and make everything send receive pairs, and then inside the send, if it detects it can't go async, then it just calls the synchronous call and calls the completion function.
the thing is that if we have 5 modules, you don't want to implement that in each module, because each would allocate
You'd have a stack of...
Yeah, and only at the highest level in the SMB VFS sum call, we would do that. In the next sum call, we won't. So, and at that layer, we would decide call through the layers with the sync function. And if some module in the middle says, no, I can't do that, we go back and do the asynchronous stuff. More questions? Okay, Jeremy?
So when are you planning to do the impersonation token changes to the VFS? Are you planning to do that in conjunction with the migration to handle-based functions or something afterwards? What's the time?
I'm not completely sure yet. So the question is when I would do the impersonation stuff. I think it might make sense to do that as soon as possible in order to get the synergy with your changes. So if you need to change something to an add function, you can already pass down the pointers. But I think it will take some time, and first we would just pass down the pointer and expect it to be null. But yeah, it's basically very similar to what you are doing.
And then the one final thing is, when we finished all this, we really need a technical document or maybe something in the wiki that essentially teaches people how to implement a sample null VFS model. Because we've migrated from basically a standard POSIX synchronous path-name-based interface to an asynchronous handle-based interface. If people aren't paying attention and they download the latest Samba code, their heads are going to explode.
Okay.
Jeremy, do a talk about it, videotape it, put it on YouTube.
Oh.
Yeah.
Yeah, I mean, because that's what happened with the original TEvent impersonation.
Yeah.
Various heads, including mine, exploded.
So the point from Jeremy is that once we do this, we should have a wiki page or so to document that, so that module writers can look up and know what they have to do. Okay, thank you.